Understanding the Microsoft Windows DNA architecture. Microsoft President Steve Ballmer caught the attention of industry observers today by introducing Windows DNA for Manufacturing, a technical architecture designed to bring software integration to manufacturing environments. Earlier this month, a new Windows DNA lab opened near Washington, D.C., the third such facility in the United States to spring up as a resource for companies building solutions on Windows DNA. Clearly, Windows DNA is gaining a strong following. But as with any new industry trend, it raises an obvious question: what exactly does this architecture have to offer? More important, what does it mean to the people it's designed to affect? Jigish Avlani, Group Manager of Windows DNA Marketing at Microsoft, explains that Windows DNA refers to the Windows Distributed Internet Application Architecture, launched by Microsoft in fall of 1997. Windows DNA is essentially a blueprint that enables corporate developers and independent software vendors, ISVs, to design and build distributed business applications using technologies that are inherent to the Windows platform, Avlani says. It consists of a conceptual model and a series of guidelines to help developers make the right choices when creating new software applications. Applications based on Windows DNA will be deployed primarily by businesses, from small companies to large enterprise organizations. Consumers are likely to use many of the applications built to take advantage of Windows DNA, such as electronic commerce websites and online banking applications. A major force driving the need for Windows DNA is the Internet, which has dramatically changed the computing landscape. 5 years ago, the process of developing programs used by one person on one computer was relatively straightforward. By contrast, some of today's most powerful applications support thousands of simultaneous users, need to run 24 hours a day, and must be accessible from a wide variety of devices, from handheld computers to high-performance workstations. To meet these demanding requirements, application developers need adequate planning tools and guidance on how to incorporate the appropriate technologies. The Windows DNA architecture addresses this need. Windows DNA, a simple technical summary. Central to Windows DNA is the concept that applications should be logically separated into partitions, called tiers. According to Avlani, this benefits developers in several ways. Partitioning an application increases its scalability. In other words, the software's ability to support a large number of simultaneous users, Avlani says. It also makes the application more manageable and easier to update. The 3 tiers of Windows DNA are: presentation or user interface, business logic, data storage. It's important to note that these 3 tiers are separations within the application. The deployment of the application can span any number of computers. Avlani cites the example of a mobile worker using a laptop computer. A Windows DNA-based application can run on that single computer, providing the benefit of access to the application at any time or any place. In the case of a large, electronic commerce website, the Windows DNA-based application might be distributed across many servers to meet that particular company's scalability requirements. This explains why people sometimes talk about Windows DNA as an N-tier or multi-tier architecture, Avlani points out. They are referring to the ability to deploy a Windows DNA-based application over any number of physical computers. COM, the cornerstone of Windows DNA. Avlani notes that Windows DNA is based on a programming model called COM, Component Object Model. The COM model has come into widespread use since its introduction by Microsoft, and it is an integral part of many Microsoft applications and technologies, including Internet Explorer and the Office suite of applications. Unlike traditional software development, which required each application to be built from scratch, COM allows developers to create complex applications using a series of small software objects. Much like cars or houses are built with standardized parts, COM lets developers make portions of their applications using components. For example, Avlani says, a component might be a tax calculation engine or the business rules for a price list. A growing number of third-party vendors sell COM components. This approach speeds up the development process by allowing several teams to work on separate parts at the same time. Developers can also reuse components from one project to the next, and they can easily swap out or update a particular component without affecting other portions of the application. COM also offers the advantage of programming language independence. That means developers can create COM components using the tools and languages they're familiar with, such as Visual Basic, C, C++, and Java. An easy way to look at it is that COM serves as the glue between the tiers of the architecture, allowing Windows DNA applications to communicate in a highly distributed environment, Avlani explains. A proven architecture with compelling benefits. To run these applications, Windows DNA relies on a rich set of integrated services supplied by the Windows platform. These services are infrastructure technologies that would be required for any scalable, distributed application, for instance, transaction processing, security, directory services, and systems management. By providing a stable base of common services, Windows DNA relieves developers from the burden of creating their own infrastructure and allows them to focus instead on delivering business solutions. The bottom line: developers save time, reduce costs, get their applications to market more quickly, and equip companies for responding proactively to changing business conditions. These benefits are especially compelling in today's competitive business climate, Avlani points out. Avlani adds several more good reasons why companies should base their applications on Windows DNA. Because the architecture is built on open protocols and industry standards, solutions from other vendors integrate easily into the environment. This helps ensure interoperability with mission-critical business applications, such as corporate databases and enterprise resource planning systems. An open approach also facilitates compatibility with existing computing systems, which means that companies can continue to take advantage of their legacy systems as opposed to replacing them. The benefits of distributed computing applications that embrace Internet technologies are many, Avlani concludes. For individuals, it means the freedom to communicate or access information at any time and from any place. For businesses, it means making more informed decisions, better understanding their customers, and responding quickly as their business needs evolve. For software developers, the challenge has been how to build these solutions. Windows DNA offers them a cohesive and proven application architecture for distributed and internet-based computing solutions. Industry support for Windows DNA. As Microsoft continues to strengthen its commitment to Windows DNA, industry support for this architecture also continues its steady rise. On 2nd February 1999, Applied Information Sciences Incorporated, AIS, teamed with Microsoft and Compaq Corp to announce the opening of a Windows DNA development laboratory in Maryland. The third of its kind, the center is providing developers in the Mid-Atlantic area with expert architectural advice and technological guidance for building applications using Windows DNA technologies. The lab is viewed as an ideal springboard for organizations trying to kick off a project, prototype new concepts, integrate new applications, or jumpstart application development using Windows DNA. The lab's intensive, hands-on educational and mentoring program offers teams of developers a wealth of practical experience and a real-world test environment, a combination they're unlikely to find elsewhere. Microsoft also teamed with Toshiba America Information Systems Incorporated and Cortec Consulting Group Incorporated to establish a Windows DNA lab in metropolitan Atlanta in October 1998. The first Windows DNA lab outside Microsoft was established in suburban Philadelphia in June 1998 as a joint venture between Microsoft, Hewlett-Packard Co. and Cortec. Microsoft established the first DNA lab at its corporate headquarters in Redmond, Wash, to assist ISVs with implementing Microsoft technologies.